We're now starting chapter 5, which marks a sort of transition point between the second part of the course and the third part of the course. Here we are both describing data, but also starting to make some predictions. So let's talk about probability and what it means in general. It means the chance of something happening. That's what probability tends to mean, and it continues to mean that in this course. Some key terms are sample space, probability model, and event. So a sample space marks all the possible results of a situation, of a chance situation. In college there are entire separate courses on probability and then statistics. When I was in college, probability was a prerequisite class for statistics. You couldn't take statistics until you had taken a course in probability, at least on a theoretical level. So this is sort of going to be the backbone of a lot of calculations later in the course. So let's start with the ideas here. We have a chance process that is happening. I'm rolling a die, let's say. And there are all sorts of possible results. The sample space is the list of all possible results. So, for example, the sample space on rolling a die would the options would be I rolled a 1, I rolled a 2, I rolled a 3, I rolled a 4, I rolled a 5, I rolled a 6. That is the entirety of the sample space. Here are the 6 possible results one can get. There's no other results you could get. I suppose it could land on an edge, but we're saying it's been rolled, so I'll kick it if it lands on an edge. Those are the only possible results. Otherwise you'd have to include a lands on an edge area separately, which might be worth having. A probability model includes both the sample space, the list of all things that can happen, and also the chance of everything happening. What is the chance of rolling a 1, 2, assuming it can't land on an edge? What's the chance of rolling a 1? 1 out of 6. What is the chance of rolling a 2? 1 out of 6. What is the chance of rolling a 3? 1/6. What's the chance of rolling a 4? 1/6. Now this is a fairly simple event, right? All the results have the same chance of happening, but that isn't always the case. An event is really any statement about what might happen. What is the chance that this would, what is, something that might happen. So here's an event that might happen. Let's call this event G for good. Event G. I roll a 5 or 6. What is the probability of event G? Probabilities of things are generally going to be written like this. P of whatever event it is. So the probability of G, in this case, is 1/6 plus 1/6, 1/3 chance of success, of rolling a good roll. What is the probability of rolling an even number? You could add together 2, 4, and 6, and that would be probability of getting an even is 1/2. Probability of rolling a 6 is 1/6, right? So you can name events with specific letters or just specify what the event is in the parentheses. Sort of like calling a function f of x or g of x. Probability of something happening is a particular number. Some basic rules about probabilities. First of all, you'll never find a probability lower than 0 or greater than 1. All probabilities are at the most 1 or at the least 0. So probability of rolling a 7 is 0. Probability of rolling a number is 1, but it's never going to be, you never have more than 100% chance of something or less than a 0% chance of something happening. And with 0 standing for 0% and 1 being 100%, naturally everything will be between 0 and 1. If you've come out with some event that's supposed to happen more than 1 of the time, more than 100% of the time, you've made a mistake somewhere in your calculations. You've added when you should have multiplied, something like that. So now let's talk about, let's talk about the complement rule. If the probability of a good roll is 1/3, what's the probability of not getting a good roll? There are two ways to write this. Sometimes it's written G with an apostrophe, the probability of not G. Sometimes it's written as the probability of the complement of G. But whenever you're trying to calculate the rest, the probability that not G, there's two ways to do this. Either you can add up all the events that aren't G, or more simply, you can take 100% and subtract the probability of actually getting that result. We've seen this already with the normal model, when somebody asked the question in class, okay, so we can calculate the probability of it being between here and here, but what's the probability of it being outside that range? Well, you can take the probability of being inside there and subtract that from 1. If it's like 62% chance of getting a result somewhere between there and there, if 62% of the data is between there and there, that means the rest, the other 38% of the data, will be outside that. That's basically using the complement rule. The rest, right? The probability of not that would be the rest. If the probability of getting a good roll is 1/3, the probability of not getting a good roll is the rest, the other 2/3. Take everything, subtract the stuff that won't do, and you have the stuff that will do. So that's pretty basic. Alright. Consider event G. Event G is really made out of two events. It's made out of getting a 5 and getting a 6, right? Now you can't get both a 5 and a 6, so you can just add those probabilities together. Getting a 5 or a 6, probability is 1/3. You can't always do that though, and let me give you an example. Event happy. Event H for happy. I like even numbers and I like big numbers. So event H will be I roll a 5 or 6, or a even number, because I like even numbers and big numbers. What I can't do, I can't just add together the probability of rolling a 5 or 6 and the probability of rolling an even number. The probability of rolling an even number is this, this, and this added together. That's half. And the probability of rolling a 5 or 6, that would be 1/3. But you can't just add them together because you'd be double counting the 6. You can only add probabilities like this if those things are mutually, if parts of them are mutually exclusive. You can't roll a 5 and a 6, so you could just add those probabilities together to get that. But since you're double counting 6 here, you can't add those probabilities together. It involves a more complicated process. You would have to say, okay, so which things work? A 2, a 4, a 5, or a 6, and then you could add those probabilities together. It's just in the book, they call it a addition rule for mutually exclusive events. If different events are mutually exclusive, the probability of this or that happening you can add those probabilities together. Let's have a break here, and I'll start a new video for the next bit.